All right. Hello, everyone. Welcome to the next stream. Let's go. Yeah, today we're gonna take a look at the Rust. I know we've been through Rust in one of the previous streams, but let's say we were more learning the Rust theoretically, and today I would like to try the Rust more hands-on, and that's why I chose this platform called Coding Game, codinggame.com. There are many coding games which you can play in many languages. Some of them are more graphical. Three of these, probably we will do just one, maybe two. This one is more graphical. If I can show you how it works, is that you have this script going over mountains and you need to shoot down the mountains apparently, and yeah, choose which one you want to shoot. And what else do we have here? We have this power of Thor. If I open it up to solve it, you have basically flying Thor, and you need to say which direction it's supposed to go. So you can see it's southwest, so it's going southwest, but you want to go him east basically, and you get the position X and Y of the light here, and then you get the initial X and Y position of Thor, and based on that you're supposed to create a program which is printing out which direction is he supposed to go. But yeah, that's not what we're gonna do today. I picked the logical gates because, to be honest, I've never been the one who is going to do these who likes to solve these mathematical and algorithmic puzzles and stuff like that. I mean, I like to develop apps because I want to build a product and stuff like that, and so I like data transformation. And I mean, I also fancy the logical gates and the logical stuff like this. So we are going to take a look at this today. All right, so I guess we can slowly start. I switched my editor to Rust here. You can see there are many languages you can use, and here's the description. So logic gate is an electronic device implementing a Boolean function performing a logical operation on one or more binary inputs, producing a single binary output. Given n input signal names and their respective data, and m output signal names with their respective type of gate, and two input signals names, provide m output signal names and their respective data in the same order as provided in the input description. All types of gates will always have two inputs and one output. Alright, it's good to know. All input signals data always have the same length. That's good. So we have basically AND, which is performing a logical AND operation. We have OR, XOR, exclusive OR, which means, I believe, not equals. Basically, we have NAND, which is negative AND, inverted AND, inverted OR, inverted XOR. Signals are represented with underscore and minus characters. So you can see down here, so number of input signals, more than or equal, more or less than or equal 4. So yeah, we can have up to 4 input signals, right, and up to 16 output signals. All gates. Let's see this example. Oh, it's broken. Try to zoom it in. Output. Okay, whatever. Oh yeah, this is the example. So 2 signals, 3 outputs. I hope this. Is there any? Yes. Okay. So here we can see the input data. 2, 3, A. Okay, so this basically this one. Here's this art output. So yeah, let's get started. So how it works here is that they have this input line. They read to IO the input line, and they parse the input, which is gonna give 32-bit signed integer. So this is n and m. N, you can see here, is the number of input signals. So here we have 2, and 3 m is the number of output signals. 3 in this case. So we have these two variables, and then we create a for loop here. And here we basically read the input, and here we have input 0 1. What's this? Okay. All right, so here we get the input signal, which is gonna be string, and here we get output name and the type, and the input name 1, input name 2. So it's like it is output name C, then we have and that's the operation type, and then we have input A and input B as the arguments, we can say. And we can use this thing for printing debugging stuff, so we can try to put it here. If I remember Rust correctly, I will do it like this, and I will put here input signal. Is it correct? If I run it, yes, there we go. Okay, so here we have the signal. So what we want to do is we want to iterate over the signal, I believe, and prepare the structure where we are going to store it. I'm thinking how we could do it. Well. Yeah, I'm thinking that we could use vectors, just like these dynamically sized arrays, basically, in Rust. And what I'm thinking is that what we could do is that we could create a vector, which is gonna be like basically for every unit of time. So like 1 unit of time, 2nd unit of time, 3rd unit of time, like 1 second, 2 seconds, 3 seconds, 4 seconds. So we can do, how do you call it? I need to translate from my Czech language to English. Sampling, yeah, of course, yeah, sampling. We're gonna do sampling, and then we would create a vector which would contain another vector with two values, and then when we are going to be performing the operations, we can search for it. But since we are having here A and B, yeah, we might Rust. Can we do hash map? Hash map new. It's key value, right? Value. Have you used hash map? Is it even possible here? This. And create new hash map. Type annotation. Explicit type. Okay, got it. So it seems like it's working. So we could say it's hash map key value. Okay, so the key would be string. Value would be what value would be uh string. Yeah, value must be vector. Well, we can do, maybe we can do array of booleans, which is size 16, because we know that the maximum amount is 16, so that might work out. Can we okay, so if I do let arrays, how do I create an array? Box. I need to, do I need to define array? How do I construct a new array? Rust. Am I able to like fill in the array with well. One way how I could do it is in, and I do input signal split, and I do or you know what, input signal how do I get what ours returns an iterator over the car of probably that's what I want. Cannot index a value of type. Wow, there's like a find map. There's, well, if there is map, that could be, how did you say the closures? Functions. Rust closures. Where are we? Okay, so okay, cool. Is correct. Ours. Fetching, zip, unzip. Take. Use for. Is there a way? Is there a way? Link to universe. My strings first. Collect. Oh, try into. Okay. Letters try into. Letters try into. And this one. Try into. This is strange. Try into. That's not right. Oh. 16. Expected array. Count atom. Result. Try it. What is this? Try into. Try. Where do we have? Performs the conversion. Result. Okay, is U. US one. Well. So basically what we want to do is we want to split the signal into array of 16 booleans because it's basically booleans. So which way input signal cars map is doing this, right? Everything true, and if I remove this signals, there is all. Any. Test every element of the. Try. Collect. What is this returning? Try collect. Change. Let S string. Come on. Oh, what was this saying? Arrays? No, I will do my string cars. I do here. I will do collect. Collect the characters into vector like this. So is it able to do this? Try collect. Come on. Come on. Unsafe library. Well, okay, so we can do collect, and it's gonna be vector what? Vector Arabic. vector boolean. Boolean, okay. And now signal. Try. How was it? Try into. And I need to say boolean 16. What? Expected array. Oh, see. This? And is there a problem? Used in a function that returns result or option. Oh. Come on. Well, I mean, I can return it, right? How do I say it? Like this? Result of I32. Right. On. Broken. Oh man. Okay. So what's underscore? What does it mean? Result underscore. No way. Result is not allowed within types. Not allowed in type signatures. Of course. Oh geez, man. Function return result Rust. How do we do it? Return result. Okay, that's a good one. Result empty. This might work. Expected struct vec boolean. What do you mean vec boolean? Count. And oh, was it here? Oh, I need to do okay. Okay, got it. So okay, so I need to put there okay. And which produces this. And what's the problem here? Expected struct. Man, I'm doing it according to this, right? Try into cars collect. Okay, so let me remove this. Cars collect. And it doesn't work anyway. And it's even worse. Oh. Or? Yeah, it still doesn't work. Come on. So, okay, so let's say, well, never mind. This is good enough. We know we have signals in vector. Yeah, that's okay. So now, and they are mapped to so if I do this debugging printing and I do signals, and then it was like this, was it? True. Yes, of course. And now what I need to do is I need to say if x equals, how was it? Operators. If on the control flow, is it? Then there was something. If condition. Okay, got it. If then it is true. If else, it's gonna be false. Now if I print it out, false, true. Okay, this is working. So that's good. So now we have these two. We have vector for every input, which transferred the signal to actual booleans in the memory. And now what? Now we need to be able to map this. So I created a hash map. And if we signals by name, I don't know. Oh, signals by name. That's a snake case in here, and this is gonna be. It's gonna be vector full of what? Full of cars. No, booleans, right? And signals by name. Is that no? How is it with hash maps? I'll just stop this one. Insert. Okay. Insert. And the key is input name. And the value is going to be signal. Okay. And if I go right here and I will do print, and I will do this, signals by name, A, and then we have B. Okay, that sounds great. So this way we have it in memory, and now we can process this we can start processing the desired output. So we want to print first thing we need to print is going to be the output name, right? Output name, then it's going to be space, and then it's going to be let fonts, which needs to be this. Let's say this. I think I can move for now. Looks good. So we have this, and now we have input. We have operation type, and then input name 1, input name. So let, and this is gonna be signal 1, and we're gonna get it. Read. Oh, what's that? Read contains key, remove. Where do I read it? Remove. Get. and we will get it by input name one. What's the problem? It's gonna be something with how was it here? Book reviews get book into find. Okay, so if I borrow it like this. Okay, so this way, as I understand it, that's the borrowing thing, where basically we need to pass there, like basically nobody else can now be reading this. If I understand correctly. Nobody else can be reading it. So now it's being handed over to get, and then it's going to be released again. So we can do signal 1, input name 2, signal 2, and what do we have here? It's option. Rust. I believe it's going to be resolved by match. Option. So we have option. X none. Sum. Okay. We need to is there any operation we can call, like unwrap? Is it? Yeah. Okay. Yeah, that's basically how we can deal with this, so that we don't have to like handle the case when it's not. Okay, this is good. This is good. Okay, so now we have these two, and we need to start iterating over them. So for E in no. Oh, it works. Okay. This one. Well. How was it? We sampling, so we can call it like for sample for time in 0 including 16, and small number, so we can do it like this, and signal 1 get, and time working, and unwrap again, let this one, then we do signal 2 S2, and we can do the debugging printing and call it like S1 equals S2 equals S1 S2, and let's see, what do we get? S1 false, false. Now we have true false. Yeah, looks good. True false. What? Two, four, two, two. What can this be? False, false. True. This. Oh, okay. Seems like. Iterators in M lines. Number of output signals. Oh, the signal one count, vector count, Rust count elements in vector. Iterator count. This right? False, 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 true. Okay, this looks better. So yeah, I mean, my whole idea previously was nonsense anyway. So this will work better. And so now we have basically these two values, and now we need to decide what operations we want to perform. And we can see, let's say, the result. And this will be vec new, and this is gonna be vector of booleans. And we will do match of type. How is the matching? Match. Like this? Is it? No, without this. And yes. Game. And result. Type. What's expected string found? How do I match string values? Rust? How to match a string against string literal? Oh, okay. Got it. Push like this. Unwrap. Yeah, this. Hey, method name unwrap font. Where's the problem? R is boolean, or what's this returning? Ensure that all possible cases are being handled. Oh. Need to handle the default case. False. And or it's gonna be one or two. X or is gonna be S1 doesn't equal S2. What's the problem? Borrowing. So if how do I differentiate? Like this. Consider borrow, removing the yeah, right now I'm not really sure what I'm doing, but it seems to be working. Borrowing Rust and opposite of reference by using is dereferencing, which is accomplished with the dereference operator. We will see some uses to deference. Okay, so I'm passing there. I guess it's like when I want to use the actual value. Section chapter 15. Chapter 15. Smartphone. Oh. Okay, assert equal. Cannot dereference. Well, let's cannot borrow result as mutable as it's not declared as mutable. Oh, I see. Interesting. Here I need to say it's mutable, but here. Oh, yeah, it's mutable. Okay. Yeah, got it. So we have our XOR, and now we need to render it. So basically, what we're gonna do is we're gonna call result map. Oh, it there map. Yes. X2 and if x true, then we are gonna do this, else this. Oh. This. No. How did I do it here? X. Oh, I need to say what it's returning, right? It's returning string. Is it? Come on, man. Found signature defined. Yes. This. And like this. Okay, so if it's true, gonna be like this, and then we need to do join. No method name join found construct. Join. I want to join. And I will change it like this. Okay. And if you see the response now, it works. So now we need to handle also other cases, and that is n, and which, if I'm not mistaken, is s1 and s2. This and or 1, 2, and or, which is gonna be like this. So let's play all the test cases and see where is the problem. It seems like it's working. Buffer or and nor XOR all the gates. Wow. Okay. All tests in one go. I mean, it took me a while. Honestly. Yeah, that's true. But all the tests in one go. That's a good result, I would say. So yeah, let's recap the code we have here. So yeah, here we get the parameters n and m, which are saying the number of input signals, number of output signals. Then based on this, we are going to iterate and read from the input. This code has been here provided by the game, so that's not me. So here we read the input name and input signal. So basically we get these two, get these numbers, we get that it's A, and then we get this whole string. Then comes the part that we do, and that's this. Let me give it better formatting. So we basically translate the input signal string to chars. That's supposed to be what? Chars. What's chars? I would say it's an array of characters, but iterate over chars. String slide struct created by chars method on the string. Well, yeah, it's probably something like vector. Not sure exactly. Public struct chars. Yeah. I'm not sure if I can read it somewhere here, but yeah, never mind. That's for next episode. So then we call map. This is what I like. This is the good part I like about JavaScript. Or I don't know which language bring it, but I know this from JavaScript. So you can transform the data through maps, reduce, filter, and all these functions. So this way we transfer transform the character to Boolean, because we know that the underscore is false and the minus sign is true. So we do it like this, and then there is this thing called collect, which transform iterator into collection. This is what I found on Google. In order to deal with well, do I need it? Maybe not. Maybe I don't need it. Yes, I need it, because yeah, it's returning map. Yeah, result like this. So this way we will make sure that it gets transformed to vector, a Boolean vector. And the next part is that we are going to use this hash map, where the key is the name of the input and the value is this vector of the signal, basically. So this way we can query the memory to search for, we'll search for the input A and we will get its signal. And the next part is that we have our output name, which is going to be, for example, C, like here. We have our type, operation type, which is and we have input name 1 and 2, which is A and B. And so the first thing we do is we will get the signal, the value of the input signals based on the desired output. So we have input name 1, input name 2. So this way we get it from the hash map, and we call this unwrap function, which is for basically not having to deal with the option value. So this way we had to add here at the top that our function is returning result, which is this way in Rust how to deal with exceptions, basically. Because obviously here item doesn't have to be the hash map, so there needs to be some way to handle this. So we're basically delegating this to later. Of course, it would be the best way to handle this, write an error message, you know, and deal with that and stuff like that, but that's not what we do here today. So the next thing is that we prepare our vector for the result. That's gonna here is gonna be the resulting signal transformed by the logical operators, and then we will iterate called the variable time, because it's basically the time or the slot during the partitioning of the signal, basically. I always forget the name. Then we can say that both of the signals are the same length. So we can say signal 1, we will get iterator from it, and we will do count operation. So this way we will get the size of the input signal. We can do it as a U size because we know it's a small number. Then we will get the same index of a signal from both of the signals. So we will read this one, this one, and this one, and this one. And what we are going to do is that we have them in Boolean format, and then we just need to call match on the type of the value of the type. So it's like and then we will do just encode Boolean operations here basically. And yeah, in case it doesn't match, we will return false, but of course it makes sense to return for example an error, you know, maybe like this. Not matching operator, is it expected? Yeah, we would have to later return like result Boolean string is it? Oh, result. Oh, we would have called okay. Okay. maybe like this, but here we would have to call unwrap. What? Expected what? Problem. Yeah, let's see. Yeah, I want to try this because, yeah, let's say that's how it's supposed to be handled, I believe. Let me know if you think otherwise. And what is the problem exactly? Well, let me remove this and see what it does. Okay, got it. Yes, unwrap. So this is like the proper way how we should handle it. This way it will throw an error and tear down the application, which is, I mean, good. So that the user knows that something went wrong. And yeah, and then we push the result, which is going to be either true or false, to our result vector. And this way the vector grows, like basically this way it grows like this by combining the input parameters. And then we basically transform the result again to iterator. We map over it and we transfer it back from boolean to string. And then we join the strings like this, and we print it out, and everything is done. Yeah, so that was it. I mean, it was not quite a fight, but I mean, you know, when you learn a new language, it's always different. Like, you're searching, you know how to get there, but you're searching for the way to express your thoughts. This, as with any language, right? So yeah, we found out how it can be done here in Rust. I mean, in the end, it's still pretty comfortable. It's still like, you know, pretty readable, understandable. You get the point. I mean, only thing here which stands out is the borrowing and these kind of stuff with Rust. But that's the reason maybe why you use Rust, right? Because it's memory safe. So you want this memory safety. So you need to treat it as your friend, not as an enemy. And yeah, then we use match here again. There's the result type, which at first can seem like an enemy, but remember, it's your friend, because in languages like JavaScript there's nothing like this, you know, and you never know if the function is going to produce any errors or not. You don't know where to catch, what to catch, you know, stuff like that. So this way you at least know what to expect, and eventually with unwrap you can decide that it's not relevant for you for now, and all app can fail, and it's okay, but you do it like knowingly. So yeah, I mean, first good impression. We passed all our tests. Let me see if I can do it like here. We see we have like check again. Yeah, like B standard outputs. We're just saying outputs, but they go like here, all gates. You know, you can see we have this 16 inputs. You can see all of them are the same length. Mega Man. Oh, it's even combining the same inputs probably. Yeah, or yeah, and trying all the possible combination, and yeah, and we passed basically. So this has been a quick guide through Rust. We tried it ourselves, like coding game. I hope you liked it. Let me know what you think about Rust. Let me know if you use it in production. I know some people use it. There was this serverless Rust, or Rust serverless website, I believe, from Benjamin, posting about it. So yeah, I mean, the hype is real. I mean, it makes sense. I mean, if we are writing applications, why do we decide to write them in a very bad performing, not optimized, full of bugs languages instead of, you know, stuff like Rust? Yeah, we all know that the problem with JavaScript was just the network effect that has been in all the browsers. So everybody started supporting JavaScript because, well, it was there, nobody had to change it, and then it grew from there to this monstrosity. And I mean, Node.js itself as the engine, you know, V8, it's great, but JavaScript as a language, well, that's a different story. All right, so that's it for today. Thank you for watching. I hope to see you at the next episode. And yeah, that's it from me. Take care. Bye.